Insert interval. Hey everyone, this is KeyStrokes. Welcome back to the channel. I'm a senior software engineer at one of the FAANGs, and I like to make videos on LeetCode problems and programming puzzles and anything and everything on computer science. And today we'll take a look at LeetCode's problem 57 that's called Insert Interval, which is a medium difficulty problem. So let's take a look at the problem statement. We are given an array of non-overlapping intervals which have a start and an end value, and they are sorted in ascending order by their start values. We are also given another interval which has a start and end value, and we need to insert that new interval in the given array of intervals, and we need to make sure that after insertion the intervals are still non-overlapping. For example, if the input intervals were 1, 3 and 6, 9, and we were asked to insert the interval 2, 5 to it, then this 2, 5 will go somewhere right here, but then 1, 3 and 2, 5 would overlap, which will merge together, which will give us 1, 5 as the final interval, and then 6, 9 as the other remaining intervals from the original interval array. Similarly, in the second example, if we are given an interval array of these elements, and we are asked to insert 4, 8 as the interval, so this new interval 4, 8 will be inserted over here, and it will go all the way until this interval. And all of these three intervals, including this new one that we inserted, will have to be merged together, giving us an interval starting from 3 going all the way to 10. And that gives us the result as 1, 2, the new merged interval 3, 10, and the remaining intervals, which is 12, 16. And the explanation says the same here. It's because the new interval 4, 8 overlaps with 3, 5, 6, 7, and 8, 10. So let's see everything that we need to know to solve this problem. We need to know some basic programming concepts like loops, and we need to know how to work on arrays data structures. Okay, so let's brainstorm on how we can solve this. Okay, so let's say we were given these intervals, which are represented by a straight line like these. And let's say if we had to insert a new interval that was positioned somewhere here. Now this new interval is not overlapping with any of the existing intervals. We can go through one interval at a time. So we'll start with this interval first, and then we'll add it to our list of intervals, which we have to return back as a response. So after this is processed, we move on to our next interval, and then we add it to our list again. Now, when we move to our next interval, in this case, we need to somehow realize that the new interval should be added before this interval that you're working on gets added to the result. One of the simplest checks that we can add is that the end of the new interval is before the start of this interval. Now, if that condition is true, then we can add our new interval to a result, as well as add this interval that we are working on to a final result. So basically, we first added this interval here, then this interval, then we added our new interval here, and then our current interval that we are working on. And now, when we move to our final interval in the array, if we run the same check again, where we check the new interval's end being before the current interval's beginning, then we might insert the new interval again. So we might need a flag, something that says inserted as true or false. So it will start as false, and the moment we perform this operation, we should switch it to true. Now if inserted is true, then we don't have to perform any of these checks to see if we still need to insert the new interval, and we can simply keep adding our intervals to the final result. And that's how we can solve this problem, at least for the case where the interval is clearly not overlapping with any of the intervals. So now, as we were running through our intervals and inserting these first two intervals to our result, how do we detect that we don't have to insert the new interval first? I think a simple check there could be that if the new interval's start is after the end of the interval that you're working on, let's say for this one here, then we can say that this interval and this new interval that we have to insert, they are not overlapping, and that this interval that we are working on is before the new interval. So let's run through this example once again with the rules that we have defined. So basically, we have the 4 intervals again and the new interval that we need to insert, and then we have a boolean flag set to false for inserted. Now we start with our first interval. Here we check if the new interval start is after this interval's end, which is true in this case, so we simply add it to our final result of intervals. Then we move on to the next interval, and we run the same check. The start of the new interval is after the end of the current interval we are working on, and so we add it to the list of intervals that we need to return. Now, when we move on to the next interval, here we check the end of the interval if it's before the start of the new interval, which is not satisfying. So we cannot move this interval here yet. Rather, now we should check another condition. if the new interval's end is right before this interval's start, which is actually true in this case. And in that case, we should move the new interval to a result and then move the interval we are working on to the result. And then flip the flag from false to true, indicating that we have inserted our new interval. Now, once it's inserted, we'll add this additional condition. If inserted is true, then there is no checks to be performed, and we can simply add these intervals to our result. So this works out for the simple case where the interval has no overlaps at all. Now let's see what the overlaps can look like. I'm envisioning the first overlap can be in the beginning of an interval, then an overlap can be towards the end of the interval, or the overlap could be across two intervals where it starts in middle of the interval and then it ends in the middle of another interval. So let's tackle one case at a time. So let's take a look at the first case where the new interval overlaps with the beginning of another interval, and I'll move the example more towards the right so that it overlaps with the third interval. Now here, for the first two intervals when we iterate, we can use the same condition where we check if the new interval's start is after the interval's end, which are for these first two intervals. And these two intervals satisfy the condition, so we simply add them to our output list. Now when we reach at this third interval, this is where things get interesting. So the first case where the beginning of the new interval should be after interval's end, that does not get satisfied. Then we had the second condition where the new interval's end should be before the interval's start. This does not get satisfied either. So we clearly know there is an overlap. Now one of the simplest way to solve this is to just merge these somehow. So basically taking this start of the new interval and taking the end of the interval that you're working on becomes our final new interval that we need to insert. So basically this new interval gets scraped and then our new interval becomes this new merged interval. And then we don't need to add this interval that we were working on because now it has been merged and has become part of this merged interval. And now this case becomes the case where this new interval is not overlapping with any of the intervals. So basically now we have three different intervals, which are these 1, 2, and 3. So this is 1, 2, and 3. And then this new interval is basically sitting right here, which becomes the case where the new interval is not overlapping with any of the other intervals. These two intervals have already been processed, and as we process this interval, it gets added to our final result, just like the previous case where we add the new interval and then we add the current interval we are working on, and then this becomes our final output. So now let's take a look at the second case where the new interval overlaps towards the end of an interval. So it basically starts in the middle of the interval and it overlaps with the interval and goes beyond it. Now again, starting our iteration, we start with the first interval. We run our condition where the new interval start is after the current interval's end, which gets satisfied. So we add it to our result. Then we do it for our second interval where the end of this interval is clearly not before the start of this new interval. So we check our second condition where the end of this interval is before interval's start, which is this, which is again not true. So this is again a case of overlapping interval. And if we apply the previous merging step again, but this time we take the start of our interval and we take the end of our new interval and create a new interval out of this and basically replace this new interval with this new merged interval that we created. Now this again becomes the case where nothing else is overlapping because we had our first interval which looked like this. Then we had our second interval which got merged with the new interval. Then we have a third and the fourth interval which are respectively right here, and none of these are overlapping anymore and they simply get added to the result list as the 4 intervals that are not overlapping. So we basically converted this case into a non-overlapping case. Now let's see the other case where the overlapping starts from one interval and goes all the way in the middle of the other interval. Now just like before, we start our first interval. The condition of this interval's end being before this interval start satisfies, so we just add it to our resultant list. And then we run the condition again, but this time for the second interval, if the new interval's start is after interval's end, which is this, but this condition does not satisfy, so we move on to our next condition where the new interval's end, which is this, is right before the interval's start, which is again not true, so we know this is an overlapping case and we're just considering these two intervals. Now let's merge them again. So this basically becomes the start of the interval and the end of the new interval. Now when we overlap this, we replace our new interval with this new merged interval, and then we don't even need to process this as we have been doing so far for the overlapping cases. But now if you notice, this case has become the case that we discussed, where the overlap happens in the beginning of an interval. So writing this again, if this was the first interval, this was the second, third, and fourth, then now this case looks like this. We had the first interval, then we have the third interval, and we have the fourth interval, and now the second interval and the new interval have merged and have become this new merged new interval, which is basically the case we just discussed. Now in this case again, we merge these, which gives us the intervals as this as the first interval, this as the new merged interval, and then this as the fourth interval. And this is how the merging has happened. And now this becomes a non-overlapping case, and we can continue with our iteration. So in summary, we have the case where a new interval is overlapping in the beginning of an interval, which is right here. Then we have a case where an interval is overlapping towards the end of an interval, which is right here. Then we have the case where the new interval overlaps with two of the intervals, which is right here and right here. And then we have the case where there is no overlap at all. Now we transform this case into this by merging these two intervals. And then upon merging these intervals, this basically becomes the case of non-overlapping intervals. And the same happens with this case, where when we merge these intervals, they again become non-overlapping intervals. So we had case 1, case 2, case 3, and case 4. So here I have the pseudocode of the solution that we just brainstormed. So let's go through this. So we have two inputs. One is the intervals, which is the array of non-overlapping intervals, and they are sorted as well. And then we have the new interval that we need to insert. We create a new result, which is basically a list that will store the intervals. And then we create a Boolean flag inserted, which is initialized to false, indicating that the new interval has not yet been inserted. Now for each of the interval in intervals, the first thing we check is if the new interval has already been inserted. If it is, then we don't have to do anything. We just need to insert the remaining intervals into result, and that's what we do. Otherwise, we run into this case where the new intervals start, which is this part, is after the current interval that we are executing in the for loop. In that case, there is no overlap, and we can simply add the interval to our result. If that's not the case, then we have this next case where the new intervals end, which is this part, is before the current intervals start, and this is the current interval start. So basically this is how things look like. And in this case, the first thing we'll do is insert new interval into a result, which we do right here. And then we insert the interval that we are working with to a result. So that means basically adding new interval and interval to a result and updating the flag inserted as true and continuing with our loop. If either of these cases are not met, then that means there's an overlap. And there are three kinds of overlap. Either the new interval starts before the interval that we are working on right now, or the new interval is overlapping somewhere after the start of the current interval that we are working on, or the new interval overlaps with two of the intervals, where the first interval is the one we are working on, and then the next interval that we would iterate on. So taking a look at the first case, in this case, all we can do is combine these intervals and update new intervals range to start from its start and go all the way to current interval's end. So basically merge these two. And we do the same for the second case, but in this case, the start becomes the current interval's start and the end becomes new interval's end. And similarly, in the third case, we treat it just like the previous case, where the start becomes interval start and the end becomes new interval's end. And once we do that, this case basically becomes the first case. And I'll show you a summary of this in a second. But let's finish our program. So these are all the cases that we go through while we are processing the intervals. But even then, if the new interval was not inserted yet, then that means it needs to be inserted towards the end. And that's what this check is about. If it's not inserted yet, we just add it to a result and then we return the result that we have been working on so far. So let's take a look at the summary of the three overlap cases that we just discussed. So this was the first case, then we had a second case and the third case. Now when we merge these, this basically becomes the first case. And when we merge these, it becomes the second if statement in our loop, where the new interval is right before the interval we are processing. And the same happens with the second case, where when we merge these, we end up with the same if case that we saw in the for loop. Okay, so I hope the brainstorming and the pseudocode helped you understand how to solve this problem. And now we can jump into our IDE to code this out. But before that, if my explanation has been helping you so far, please don't forget to like this video and to subscribe to my channel, and please do support me by buying me some coffee. If you'd like, you can have one-on-ones with me where I can help you with learning how to code, interview preparations, consulting on project ideas and its execution, and really anything and everything about computer science. If this interests you, please feel free to reach out to me through the Google form that you'll find in the description. Okay, so let's jump into our IDE and code this out. Okay, so here I have IntelliJ where I have a solution class with the function insert, which follows the same signature as the LeetCode problem, which we can see right here. It takes in the input intervals, which is a 2D integer array, and then it takes in a new interval, which is just an integer array, and then in response, we are supposed to return a two-dimensional integer array. So the first thing we'll do here is create a new array list, which we'll use to return our results. So we'll do final array list, and we'll create this array list of an array of integers where each element will be an interval, and we'll call it, let's say, result, and it will be new array list. Next, we'll create a boolean which will track if the new interval has already been inserted. To start with, we'll set the value as false, and now we are ready for our iteration. So we'll run a for loop on the intervals that we have. We can do for int interval of intervals, and in here the first thing we'll take is the start interval, which can be stored in this interval start, and this will be the first index of the interval, and similarly we'll store the interval n in the interval end variable, which will be the first index. Now we have a base case. If we have already inserted our new interval, then we don't really have to do much. We can simply push the interval that we are iterating on into the results. So we can do result.add and then a new int of interval start and interval end. Otherwise, we'll write our first condition, which is the new interval's start is greater than the interval end, which is basically this case. Let's say if our interval is represented by these hyphen lines, and then we have new interval, which we are hoping is after the end of the interval on the top. So basically this is the end of our current interval, and the new interval starts after this interval ends. In this case, we can simply add the interval to our result. So we'll do the same thing as we did here for inserted flag. So copying and pasting the same thing right here. Otherwise, we'll have another condition. So I'll copy this, else if. Now this time it will be in reverse. We'll check if the new interval's end is before the interval start. That is this case, where the interval's beginning is coming after the end of this interval. Now in this case, we can simply add the new interval to our result as well as the interval and mark our inserted flag as true because we just inserted the new interval. So copying this again. So first we'll insert the new interval because this comes before the interval, and that will be new interval 0th index, new interval first index, and then we insert the interval itself. And then we'll switch the flag to be true because we have inserted our new interval in there. But if none of these are true, that means there's an overlap between the new interval and the interval that you're working on. That is, there are different cases. If this is the interval we are working on, then there could be an overlap towards the end. Otherwise, if this is the interval we are working on, then the overlap could be towards the beginning. Or if this is the interval that you're working on, the overlap could be with the end of this interval as well as an overlap with the next interval. So this becomes, let's say, case 1, this becomes case 2, and this becomes case 3. So in these cases, we'll basically merge these intervals. So this is how it will look like. Let's call it merged. And if I copy this interval, we'll take these two intervals and we'll merge them together. So basically in the end, this will just look like one straight line where both the intervals are merged. Similarly, for the next case, the merged interval will look like this, where the starting will be the beginning of the new interval and the end will be the end of the interval itself. So this becomes the merged interval. Now for this case, we'll start by treating this as case 1, where we are working on this interval and then we merge it. So this will first become like this, where this interval and this interval got merged. But now this merged interval itself is overlapping with this next interval, which then becomes the case number 2. And on the next iteration, that's what we'll deal with, which again further gets merged to get extended further. And so all the 3 intervals get merged into one long interval. So how will this look like? We can simply do new interval of 0 equal to math.min, and we're using min because this is the start of the interval and we want the earliest start. So this becomes new interval 0 and the interval start that we're working on. Similarly, the end of this new interval gets updated to math.max. And this time we take new intervals end, which we find at the first index, and then interval start becomes interval end. And then after this loop is done, we add one more base case towards the end. If the new interval is still not inserted, that means it should be inserted towards the end of all the intervals. So we can simply insert the new interval towards the end, and that should be it. Now result has all the intervals and the new interval added together such that they're not overlapping. And our result right now is an array list. So we just need to return a 2D array out of it. And for that we can do result.toArray and basically a new integer. I have a main program here. We have a bunch of example cases from LeetCode, and this uses our solution class. So let's run these examples and see if our test cases pass. And yes, looks like we get all the correct answers. So let's copy this program and paste it on LeetCode and see if it works. So copying all of this, going to LeetCode and replacing this function and running it for the base cases. We see that it was accepted for the base cases. Now let's submit this for the actual test cases. And yes, this was successful and all the test cases passed. Well, that's all I had for this video. If this was helpful, then please don't forget to like this video and to subscribe to my channel. And you can follow me on Twitter and you can show me your support by buying me some coffee, and feel free to reach out to me to have any one-on-ones with me if that interests you. I'm working on more videos, and until then, you might want to challenge yourself with the question on the screen. Thank you so much for joining in. I'll see you next time.